How large language models work. Over the past few years, you may have noticed computers getting surprisingly good at writing and conversation. You can ask a question and receive a detailed explanation. You can request a summary of a long document. You can even ask for help writing code or drafting an email. Systems that perform these tasks are called large language models. Despite the impressive results, the underlying idea is not magic and it is not human-level understanding. Instead, these models rely on mathematics, probability, and extremely large datasets to predict language patterns. So today we are going to walk through how large language models actually work and why they have become such an important part of modern artificial intelligence. Chapter 1. What a large language model is. A large language model is a type of artificial intelligence system designed to understand and generate text. The term large refers to both the size of the neural network and the amount of data used during training. These systems analyze enormous collections of written material such as books, articles, and web pages. During training, they learn patterns that describe how words typically appear together. The goal is not to memorize every sentence in the data. The goal is to learn statistical relationships between words and phrases. Once the training process is complete, the model can generate new sentences based on those patterns. Chapter 2. Tokens instead of words. Before a model can analyze language, the text must be converted into a numerical format that computers can process. This is done by breaking sentences into smaller units called tokens. A token may represent a word, part of a word, or sometimes a punctuation mark. Each token is assigned a numerical identifier. This allows the model to process language as sequences of numbers rather than letters. By working with tokens, the system can analyze the structure of sentences in a consistent mathematical form. Chapter 3. Neural networks behind the scenes. Large language models rely on neural networks. A neural network is a system made up of many interconnected computational units. These units perform calculations that transform the input data step by step. Each connection in the network has a weight that influences how information flows through the system. During training, the model adjusts these weights repeatedly. The adjustments help the network learn patterns that appear frequently in the training data. The final result is a model capable of predicting the next token in a sequence with surprising accuracy. Chapter 4. The prediction game. One of the simplest ways to understand language models is to think of them as prediction systems. During training, the model repeatedly sees sentences with one token missing. Its task is to predict what token should appear next. For example, if the input is "the sky is," the model may predict the token blue. This process happens billions of times across enormous data sets. Over time, the model becomes better at estimating which words are most likely to follow others in different contexts. Chapter 5. Transformers and attention. Most modern language models are built using a neural network architecture called a transformer. Transformers use a mechanism known as attention. Attention allows the model to examine relationships between words in a sentence. For example, when reading a long sentence, the model can focus on words that influence each other. This helps the system understand context rather than treating every word independently. Attention mechanisms make it easier for the model to process long passages of text. Chapter 6. Training on enormous data. Training a large language model requires enormous datasets and significant computing power. The training process may involve billions or even trillions of tokens. Powerful computer clusters perform the calculations needed to adjust the model's internal parameters. This process can take weeks or months depending on the size of the model. The result is a system with billions of adjustable parameters representing learned language patterns. Chapter 7. Generating text responses. When you interact with a language model, the process resembles the prediction task used during training. You provide a prompt containing some text. The model analyzes the tokens in that prompt and predicts the most likely next token. That predicted token is added to the sequence. The model then repeats the process to generate the next token. By repeating this prediction step many times, the model produces a full response sentence by sentence. Chapter 8. Why models sometimes make mistakes. Large language models generate text based on probabilities rather than factual verification. They produce answers that are statistically likely based on their training data. Because of this, they can sometimes produce incorrect or misleading information. The model is not checking a database of verified facts. It is predicting language patterns that appear plausible within the context of the prompt. This is why human judgment remains important when evaluating AI-generated information. Chapter 9. Real-world applications. Large language models are now used in many different applications. They help power chatbots and virtual assistants. They assist programmers by suggesting code. They summarize documents and translate languages. They can even help generate educational explanations or creative writing prompts. While the technology continues evolving, these systems are already becoming useful tools for a wide range of tasks involving language. To wrap up, large language models are artificial intelligence systems trained to understand and generate text. They convert language into tokens, analyze patterns using neural networks, and predict the next token in a sequence. Transformers and attention mechanisms allow them to understand context across long passages of text. By training on massive datasets, these models learn statistical patterns that allow them to generate surprisingly coherent responses. Although they are powerful tools, they rely on probability rather than true understanding. Knowing how they work helps explain both their strengths and their limitations. This has been a mini Leviathan production. If you enjoyed it, check out our other videos. Comment below what other topics you would like us to cover. See you in the next one.